Previously, you learned that two polygons are congruent if their side lengths are the same and if their angles are the same. But in this lesson, we're going to learn that with triangles, there are some shortcuts that we can use to prove that we have two triangles that are congruent. So we're going to talk about what is called the side-side-side, side-angle-side, angle-side-angle, and the angle-angle-side postulates and theorems. And so starting with what we call the side-side-side postulate. What this says is that if we have three congruent sides, then that is enough to prove that we have two triangles that are congruent. And it's a postulate because if you just think through this and try to draw yourself a picture, this really is kind of intuitive. So here we see one triangle on the left, and then we're going to try to draw another triangle with all of the same side lengths as the first triangle. So we see the red line already drawn for us, and then we have a blue line and a yellow line that we need to reproduce over here. So let's draw a blue line and a yellow line with the same length as the first triangle. So we just drew them randomly, and the only way to make a triangle with those side lengths is if we were to bring them together like this. Notice the only way to make a triangle with those side lengths is if we have a triangle that's identical to the first triangle. So just by drawing this picture out, we can see that if three sides are the same to three other sides on the other triangle, then we can conclude that we have congruent triangles. And thus, not only are the side lengths the same, but now this angle would be congruent to this angle, the angle on the top would be congruent to this angle on the top, and then this angle on the right to this angle on the right. So that is the first postulate, called the side-side-side postulate. And here is some examples with actual numbers and maybe some other ways you might see this. Here's example 1. We see that we have this length of 8 that is congruent to this length of 8. This length of 8 is the same as this length over here, and then the bottom is the same as this bottom. So because we have three sides that are congruent to the other three sides of the triangle, then we can conclude that we have congruent triangles. And instead of writing numbers, you could just put the lines in them. So no numbers included, you could just put the lines to show that we have congruent sides, and thus we have congruent triangles. The next postulate is called the side-angle-side postulate, meaning if we have a side congruent to another side, and then an angle congruent to this other angle, and then another side congruent to this other side, then we have congruent triangles. So notice on the right side over here, I created three segments with the same length as the first triangle, and this angle in the middle is the same as this one over here. So I've reproduced this identically to the first one, and now this third side though, we don't know the angle and which way it's going to be facing. But if you just try to draw this out, the only way to make this third side meet is to bring it back down to here. So if you just think through this, you can see that the only way to create two triangles with the side-angle-side congruent to a side-angle-side is if we have totally congruent triangles. So just having a side angle and side congruent to another side angle side is enough to prove that we have congruent triangles. And therefore, the yellow sides are the same now because we have congruent triangles. And the top angle would be the same. And the right angles over here, the angles on the right, would be the same as well. So here's an example where we have one side congruent to a side over here, an angle congruent to an angle, and then the side congruent to the side. So because of this, we can conclude that we have congruent triangles because we have two sides and an angle in between. And by the way, with a side-angle-side postulate, to have congruent triangles, this angle needs to be included between the two sides, meaning the angle cannot be over here or it cannot be up here. It's got to be in between these two sides. So these two would not work. And then here's another example. If all we had were just the lines through it, this would show that we have congruent segments. So the one line through means those segments are congruent. Having the two lines through means that those two segments are congruent. And then having this angle symbol on the bottom left shows that those two angles are congruent. So we have a side and an angle and a side congruent to a side angle side, and the angles in between those two sides. So therefore these two triangles are congruent. And therefore, because they're congruent, this third side is the same, and then this top angle is the same as this one, and then this third angle would be the same as this one. Next we have what is called the angle-side angle postulate, meaning if we have an angle and another angle and then a side in between those two angles that are congruent to the same angle, side angle on the other triangle, then we have congruent triangles. So notice on the left is our original triangle. On the right we have an angle, a side, and an angle. So we know that the other two segments are going to be the same length. And the question is there another way to make a different triangle using the same side lengths over here and using these angles? Well, if we draw this red line at the bottom, we know that it needs to have this angle right here. So we can start here at this vertex, but it's got to go at that angle. So it's going to look like that. And the yellow line, same thing up here. We just drew that in. It's got to be up at this angle. So it's going to start here and it's got to be going down at this angle. So if you have that, we see that the only triangle that we can create would be a congruent triangle to the original. So if we have an angle, a side, and an angle, where the side is in between the two angles, then we can conclude that we have congruent triangles. Here's an example with actual numbers. Notice we have a 50-degree angle that's congruent to this 50-degree angle, a side congruent to this side, and then this 80-degree angle congruent to this 80-degree angle. So therefore, because we have an angle, side, and angle congruent to an angle, side, angle, where the side is in between the two angles, then we can conclude that we have congruent triangles. And therefore, the other side on the right would be congruent, and then the sides on the bottom would also be congruent, and then this third angle over here would be congruent to this third angle. And instead of putting the numbers, we could just have the symbols, where we have an angle, side, and angle congruent to an angle, side, angle. These would also be congruent triangles. Now we have what's called an angle-angle-side theorem, and this one needs to be proven. And this one says if you have angle B congruent to angle E, so the bottom left angles, and angle C is congruent to angle F, so the bottom right angles, and then AC is congruent to DF, so the segment here on the right. If those are congruent, then the theorem says that those triangles are also congruent. So proving this, we can do this pretty quick because the first statement is going to be the given statement, and the reason is because it is given. And then if we know that two angles are congruent to two other angles to the other triangle, then the third angle must be congruent to the third angle up here. So we can say that angle A and D are congruent because we have two angles congruent to two other angles. So that means the third angle must be congruent as well. So now notice the angle on the top, and then this side right here, DF, and then this angle is congruent to the angle on top, this segment, and then this angle. So what we have is an angle, side, angle congruent to another angle, side, and angle. So therefore, we can conclude we have congruent triangles because of the angle, side, angle postulate. So now we can say that if we just have two angles and a side that are congruent to two angles and a side, then we can conclude we have congruent triangles. And notice that it's different than angle, side, angle. Angle, side, angle, the side is in between the two angles. Whereas angle, angle, side, the side is not between the two angles. So that would be the difference between those two. Now here's an example of the angle-angle-side theorem. Example 1, we see that we have one angle congruent to another angle, and then this side is, or this angle is congruent to this angle, and then this side is congruent to this side. So because we have two angles congruent to two angles, and then this third side is congruent to this third side, we can conclude that we have congruent triangles. And by the way, this would not work if, let's say, this first triangle were the same, but then instead of this side being congruent, and instead of that side being 5 inches, maybe we have this side over here that was 5 inches instead. So notice that the relative location of those congruent segments are not the same, so therefore we would not have congruent triangles, because we have this angle, that angle, and then this side, 130, 20, and 5. If you go in the same order, go from the 130 degree angle to the 20 degree angle, this side would correspond, so this side over here would correspond with this side. So this would correspond with this, and the only way that these would be congruent is if those two sides were congruent. So the 5 inches needs to be here where it was, not over here on the side. And then here's another example where we have an angle, angle side congruent to an angle, angle side. And notice the side that's congruent is next to the angle with the two lines or two arcs around it or through it. Whereas if this segment were up here that was congruent, that would not be congruent triangles, because this side is next to the angle with the one arc, and this one is next to the angle with the two arcs. So take note of that little nuance. Next we have what is called the hypotenuse leg theorem. In the hypotenuse leg theorem, what that says is if we have a right triangle, or two right triangles, and we have the hypotenuses that are congruent and the legs that are congruent, then we can conclude that the two triangles must be congruent. Now, an informal proof of this would be putting in actual numbers. And let's see what we get for this third side. So with Pythagorean theorem, we know that c squared equals a squared plus b squared, where c is going to be the hypotenuse, which is across from the right angle. So across from this right angle would be your c. So 13 is c in both cases. So if you plug numbers into the Pythagorean theorem, we'd have 13 squared equals, and then we'll let 6 be a, so 6 squared plus b squared. 13 squared is 169, 6 squared is 36. So we can solve this for b by subtracting 36 from both sides. So now we have b squared equals 133. And then take the square root of both sides. So we get b equals the square root of 133. And so from here, we can then do the same thing for the other triangle, but notice that it's the same numbers that we're plugging in. So this would be the square root of 133, but then this over here would also be the square root of 133. So now we have three congruent sides, which is proving that we have congruent triangles because we have the side, side, side postulate at this point. So we can conclude that anytime we have the hypotenuse and leg congruent to another hypotenuse and leg, then we have congruent triangles. And then lastly, putting everything together with overlapping triangles, our objective is to determine if we have congruent triangles, and if so, which triangles are congruent, and then what is the reason. So notice I can separate these two triangles, where if CA and CE are congruent or equal, I separate these, so now we have two triangles. So we separate them, and the two triangles will look like this. And notice that when I separate, this angle up here is being shared with both triangles. So this angle is congruent to that angle over here. So notice we have an angle side angle congruent to an angle side angle, and the side is in between the two angles. So therefore we can conclude, because of angle side angle, we do have congruent triangles, where the A corresponds with the E, the C corresponds with the C, and then the D corresponds with the B. So I can write this as CAD is congruent to CEB. Make sure the order is the same, where the corresponding parts, the corresponding vertices, are in the same order for both triangles. And that concludes our lesson for today. We will see you next time.